Assalamualaikum warahmatullahi taala wabarakatuh. My name is Kamarul Afiq bin Kamarudin. Okay, for this chapter, which is coordinate system, I will explain two main points. That are coordinate system and differential for length,
coordinate
surface, and
system
volume.
it divided into three. That's are Cartesian, cylindrical. For the first main coordinate system is Cartesian. In Cartesian, we have 3 points. They are point A, point B, and point C. Point A is from origin to A, point B from origin to B, point C origin to C. The equation for the Cartesian is the vector A equal to AX vector X plus AY vector Y plus AZ vector Z. For the range for X, Y and Z is from negative infinity to positive infinity. For X, negative infinity to positive infinity. For Y, negative infinity to positive infinity. And for Z, positive infinity. For the number 2, we have cylindrical. For the cylindrical, we must have rho, V and Z. For the rho is the radius of the circle, while V the angle for this, and Z is the height of the cylinder. Okay, the equation for the cylindrical is the vector A equal to A rho times the vector of rho plus A V multiplied by the vector of V plus AZ multiplied by the vector of Z. For the range, first for V, for rho, from 0 to positive infinity. For V, from 0 to 2 pi. And lastly for Z, negative infinity to positive infinity. Because okay, for the spherical, for the main coordinate system, we must have radius, which is r, v and theta for the spherical. The vector A for the spherical equal to AR times the vector of r plus A theta times the vector of theta times A v times the vector of v. For the range of r, 0 to positive infinity, start here to positive infinity. For theta, 0 to pi, and for v, 0 to okay, we will move to other point, which is differential for length, surface and volume. Okay, we will talk first about differential length for Cartesian coordinates. This is example for differential for length. Number 1, dl1, number 2, dl2, dl3, dl4 and dl5. For differential dl1, we will get dz az, because positive the az direction of az to up, so we will get positive az. dl2 dy ay, we will get ay positive because the direction of ay is to infinity, positive infinity. Okay, for dl3 dz negative az, because the direction of az to negative infinity. dl4 dx negative ax, because the direction of ax to infinity, negative infinity. While dl5 dx ax, we get
positive AX because the direction of AX is okay. For differential surface for Cartesian coordinate, I have 4 example. That's are ds1, d surface 1, d surface 2, d surface 3, and d surface 4. For d surface 1, this is this point, we will get dx, dz, negative ay. We get dx, dz because this point is on y plane, so we call ay direction. We get negative ay because this plane is on negative infinity. So for the d surface 2, dy dz ax, this point is on x plane, so we will get dy dz ax direction. For the surface 3, dx dz ay direction. This point is on y plane, so we get positive ay direction because it on positive infinity side. For last, the surface 4, dx dy negative az direction. We get this because is on z. For the last differential for Cartesian coordinate is volume. From this cube, we need to differentiate it for dv, so we will get volume. We need to use triple integral to integrate dx, dy, and dz. So we will integrate dx, integrate dy, and integrate dz. So we will get the volume equal to okay. For number 2, cylindrical coordinate, we can differentiate it into length, surface, and volume. Okay, we will talk first about length. So we have 4 example for length, which is the length 1, the length 2, the length 3, the length 4, or the L1, the L2, the L3, and the L4. For the L1, we will get dz az. We get this because it's on z axis. For the L2, we will get the arrow. It is on rho plane, arrow axis, and the length 3, the L3, the rho negative arrow because the direction to negative, and the length, the L4, rho, dv, and f. Okay, for number 2, we can differentiate into surface for cylindrical coordinate. I have 3 example, which is the surface 1, the surface 2, the surface 3. For the S1, after we differentiate, we will get the rho dz af. For the surface 2, rho dv, the rho az. And example for the surface 3, we will get rho dv dz and a. Okay, for the last differential for cylindrical coordinate is volume. So we need to integrate dv to get volume. Using triple integral, we need to integrate rho d rho with the limit rho to rho, assume s rho, integrate dv 0 to 2 pi, and integrate dz 0 to z. So we will get rho square over 2 times 2 pi times z. So we will get the equation for the volume is pi Okay, we go
square
for the
and
last,
z.
which is spherical coordinate for differential. It also has three. There's length, surface, and volume. Okay, for the length, I have three example here. That's the L1, the L2, and the L3. Okay, for the L1, we got R, d theta, and a theta because it lies on theta path. For the L2, we get dr, ar because it on r path. And for the L3, we got r sin theta, d phi, and a phi because it on phi. Okay, for differential surface, I have three example. That's for the S1, the S2, and the S3. That also means the surface 1, the surface 2, and the surface 3. Okay, for the S1, we will get r dr d theta times negative a phi because negative is on left, so ada we can say on negative infinity its range. So for the surface 2, we will get r sin theta dr d phi a theta. We got a theta because it on theta path, that's round, so we will use dr and d phi because because this our a theta. So the surface ring we get r dr d theta and a phi. We use dr and d theta because here we get a phi. And lastly, for the volume, we need to integrate dv, so we will use triple integrate to integrate r cube r square sin theta dr d theta and d phi. So we will get the volume is the limit for dr 0 to r, integrate r square dr, integrate sin theta d theta, and the limit 0 to pi, integrate the phi using 0 to 2 pi limit. So we get r cube over 3 times 90 cos theta, that we need to insert pi and 0 into this and time 2 pi, so we get r cube over 3 times 2 times 2 pi. So the answer we get for for the last, we must know in this topic, which is conversion of coordinate system. In this title we have 2 points. The number 1, and that's cylindrical to Cartesian or Cartesian to cylindrical. This is rho, this is phi, this is z. So for y, rho sin theta, for x, rho cos theta. So we will get the volume of the answer for rho using this formula, x square plus y square and square root the answer, the sum of x square and plus y square for Cartesian to cylindrical. And we also can get the answer for phi from this formula, that's tan inverse times y over x. Y z value of z is same for value of z for cylindrical. After that, now point number 2 is spherical to Cartesian and or Cartesian to spherical. We can get value of r, phi and theta from the formula. So we can get r from x square plus y square plus z square and square root the answer of this sum, and we can get
phi from this formula. That's same for cylindrical to Cartesian. That's tan inverse y over x. And for the pi, we can get using tan inverse x square plus y square, square root the answer, and divide by z. So that's all from me for this topic. I hope you can get some information from my lecture. Thank you for listening.